right? Done. Nice proof, right? Simple, straight, obvious. Okay. Now we can move on to the algorithm. Now we are clear that if it is strictly convex, it looks like this. Now, how do you come up with some kind of an algorithm that takes you to the bottom, right here? Why do you need that? Well, in neural network kind of applications, we saw that, right? We need to minimize the loss. That means I want my loss to be as small as possible. That means I have to go to the deep valley and be there, right? So how do you move into that deep valley? So let's start with that. Let f r into r be a convex function. Then, well, I can also say strictly, okay? Well, not really. I can just stick to convex because strictly I'll go to the global optima, global unique minima. If it is not strictly, I'll go to the minima, right? It need not be global, like a bucket, right? You can pick any point. All that I care about is, I want to go to one of those points, right? So I don't care about, I have to reach the bottom of the bucket, right? So I don't care where. Okay. Then, how do you solve this problem? Okay, minimize overall x f of x. Of course, this x belongs to. This is called an unconstrained optimization problem. Optimization. So, in many of the machine learning applications, especially involving neural networks, mostly it will be unconstrained. Even if you regularize, it will be unconstrained. Okay, so all that we care about is solving unconstrained optimization problem. But if you look at data analysis in general, of course, there are many problems where you have constraints as well. Okay, so at least we will start with this. If you can solve this, maybe you can solve the bigger problem as well. Okay, so now what is the solution, right? What is the solution? You take the gradient, equate it to 0 and find the point, right? Derivative equated to 0, find x. Strictly convex, you will get a unique minima, right? That's how you do it. But finding the gradient equation can be very, very complicated, right? For example, some e power x plus minus log of 1 plus x, right? So very complicated function. Maybe you can solve, I don't know. Yeah, you cannot solve. It's like a complex function, right? So how do you solve? You come up with an algorithm, right? So what is that algorithm? It's called gradient descent, right? How many of you have heard of or already studied gradient descent? Can you please raise your hand? All of you? Yes or no? All. What about others? No? Which course did you study gradient descent? A course taught here or? PRML. Okay, what did you study in PRML? So you studied gradient descent, but what else in gradient descent? Okay, forget about stochasticity. So what else did you study? Did you study convergence? No. Okay, good. At least have some story to say, right? So let's start with gradient descent. Moving forward, I'll call it as GD for short. Okay, so I'll use GD. Now, what is a gradient descent? So how do you write the algorithm, right? So this is how you typically write the algorithm, right? So it's gradient descent. Okay, so what do? You run this algorithm t times. So essentially, input x0 belong to domain of f. So you take the initial point. So what do? I run a loop, right? For t equal to 0, 1, etc. I'll run till t, capital T, and I'll stop after that. So you do what? You do, maybe I'll, okay, t is fine.